Okay, firstly, good afternoon, yeah? That'll do. It still feels like morning, but we'll call it afternoon, we'll go with that. Good afternoon everyone, and a big thank you for coming and listening to the talk. It's always appreciated to see nice gaggle of faces in the theatre. So basically this talk is going to be another one of what I did on my summer holiday type talks, I'm afraid. Sort of, when I last saw you all, it was probably Wakefield in April, and now it's October, so it seemed like a reasonable thing to bring you up to date on. So basically, the summer has largely been focused on two things for me, or three things. NVMe and computers running on NVMe storage, getting RISC OS Direct ready, and doing operating system upgrades for all our systems, and new monitor technology, which we're demonstrating on the stand today, which I can't really show very much here on, but I'll talk about briefly as we go. I brought a fair few props to hold up, so we'll talk about a few things. But the main machine I'm going to be using today to demo is one of the Hydra systems that we launched last year, which has been upgraded over the year or so with NVMe technology, which makes it a much more exciting product than it already was. But first, let's start on upgrades, because that took an awful lot of time over the summer. So we did upgrades for all of our existing systems that are still active, from RMX6 upwards. It was, I think, 11 different platforms we upgraded in the summer, across 7 different generations. So it's probably the single biggest rollout of operating system upgrades and things that has ever been attempted in the RISC OS world. It was quite a biggie, so it took probably the best part of 6 to 8 weeks to get all of those rolled out, but we have now done those, and those upgrades, for those who are unfamiliar, we have special software that will sort of guide people through the upgrade, allow you to roll on or roll back if there's things that you don't like, and sort of automates the process. So basically it's a safe and secure way of doing all the updates to your computer. And so rolling out those and testing them all the different machines was quite a time-consuming job, as you might imagine. But it means that basically, I mean, the RMX6 is 10 years old, would you believe now? So basically, anybody with a computer from ours up to at least 10 years is now bang on the state-of-the-art versions and brought bang up to date. Then he was on to doing RISC OS Direct 5.31, which Richard, I'm sure, has told you all about in the earlier talk. That will have roll-on results. Obviously, we wanted to get that out first, but a lot of our more modern machines, from sort of, I think, the original Pinebook onwards, certainly the original Forte onwards, run something called Direct Plus, which is basically their operating system and disk image is an expanded upon version of RISC OS Direct for easy maintenance. So that means that we'll be able to roll out versions of that, essentially trimmed versions of RISC OS Direct upgraded, but suitable for those machines. And that will be able to be rolled out very quickly. So I'm hoping that we'll be able to roll those additional software elements out in the next couple of weeks for everybody who's got one of those machines. RMX6, we will be doing it for those as well, but it will, because that didn't use RISC OS Direct, I've got to sort of move things around a bit, match it to the RMX6, so it's a little bit more time consuming. So expect more updates sort of in the next few weeks, to match in what we've been doing with RISC OS Direct and bringing everything up to date. I mean, what was kind of amazing was the RMX6, a 10-year-old machine, and we were still able to introduce a major new feature. So RMX6 got Wi-Fi support 10 years after we launched it, which is pretty amazing. That, there aren't many computers where you suddenly get like a major new feature 10 years into the life of the computer, but it was pretty cool. So that was a good one to roll out. But basically, we did RMX6, we did the various titanium machines, the various Pi machines, Next, MiniPi, Minim, Hydra, and so on. So basically all the range plus the Pinebooks. Speaking of Pinebooks, I won't do too much on the Pinebook Pro because most of you will have seen the Pinebook Pro already. If you haven't, do come and have a look at the stand. Pinebook Pro has gained Wi-Fi, as you probably read, and it's also worth mentioning that Pinebook Pro is capable of taking an NVMe storage as well. So when I'm talking about NVMe storage and the future of storage project next, also applies to the Pinebook Pro. So you can have high-speed next-generation storage and Wi-Fi on a laptop in RISC OS. It's pretty cool. But the important fact to let you know, because I only found this out last week, is that the company that manufactures the chassis, Pine, are calling last orders on the chassis now. So we have put in an order. Basically, we've taken the rest of their stock that they've got available. Basically, my email to them was, how many can you supply, and we'll take them. Because the replacement product that they're going to come out with will almost certainly be 64-bit only. So we won't be able to run RISC OS natively on the new products. So obviously we want to get the stock, but it does mean if you are interested in Pinebook, you've been mulling it over, maybe you're thinking, oh, I'll get one next year. You might want to order one at the show or thereabouts, because once this batch is gone, there won't be any more Pinebook Pros. So do get your orders in if you are interested in Pinebook Pros. So yeah, I mean, basically. All the computers that we're showing on the stand represent state-of-the-art of RISC OS. That typically means processors at a minimum of 1.8 gigahertz, but you can go higher to 2.1 gigahertz. NVMe storage, graphics up to 4K, high refresh rate monitor support, and so on. So whether it's a Hydra or something even as small and trivial as the Mini Pi, all of the systems will give you state-of-the-art technology, laptop, Mini, Hydra, everything. Now, stopping just to explain NVMe to you, because it's important to understand what NVMe is, because I'm going to talk a lot about it. Your old RISC PCs had hard drives. Things like the ARM X shipped with solid-state disks. The solid-state disk traditionally was connected to what we call a SATA interface. And SATA came out of replaced the old IDE controllers that you had in a RISC PC, but it started, SATA was designed in an era of mechanical hard drives, so the SATA protocol is very much based around the idea of the requirements of a mechanical hard drive era. There are whole command sets dedicated to making sure that the heads get things in the right order as the disk spins, and also NCQ, native command queuing, so that it can, if it needs this, then this, then this, it can get it in one pass. Basically, it's a technology designed around mechanical drives. And of course, solid-state disks can pretend to be mechanical hard drives for the purposes of protocols, but they're a very different concept, because instead of having things spinning around and having different access times, solid-state disks, every byte of a solid-state disk is instantly accessible. And they probably have more in common with memory, with RAM, than they do with a traditional mechanical hard drive. So basically, the rest of the world decided that actually using the same connections and what have you for flash solid-state disks as mechanical hard disks wasn't the best plan in the world. So what they decided to do was connect the flash storage directly to the fastest bus on the computer, which is the PCI Express bus. And basically, PCI Express maps directly into the computer's memory and allows data to be transferred directly into the computer's memory from memory chips to memory chips, essentially. Getting rid of all the sort of cruft of the cabling and everything, the packetized transfer that was required for SATA drives. And basically you just say, this chunk of flash goes into this section of memory and zoom. And so that's what these NVMe drives are all about, basically providing solid-state storage in a way that maps it directly into the processor, to the memory, in the most efficient and most sensible way possible. And the PC Mac world, that, because they've got very fast PCI Express buses, that can allow for thousands of megabytes a second. In the RISC OS world, because things like the Pis and the rock chips have limited amounts of lanes of PCI Express, you do have a maximum peak of around 500 megabytes a second. But basically this means that we can leverage solid-state disks to the fastest way we can, and break the limits that sort of SATA drives through imposed on machines like the ARM-X6 and Titanium and what have you. It feels like
it's got switched off somehow.
I seem to have lost my communication.
It was fading away.
I think we must have. Oh, I'm back.
You're back.
Yeah. Too fat. That's
Well, it wasn't. Richard did exactly the same thing. So.
I don't know what the feeling is at RISC OS developments. So basically, NVMe provides essentially the most modern and state-of-the-art technology for storage. It's also much more efficient for smaller files because you have fewer overheads in the process, so that's very well suited to RISC OS. So basically, NVMe storage tends to give the best possible experience that you can have on RISC OS. So we actually started developing NVMe storage quite a long time ago for the Pinebook Pro originally, because that was the first machine to, because that had a native slot for NVMe in the sort of front of the machine, ahead of everything else. So that was our sort of first target platform, and our programmer actually, that was his motivation for wanting to do NVMe, was he got Pinebook Pro, and he was thrilled to bits with it, but he saw that there was this vacant slot for an NVMe drive and he really wanted to fill it with it. But he'd actually bought the wrong thing for his PC, so he got this drive, he didn't want to stick it in his Pinebook, couldn't do it, so he said, Andrew, if I write, should we do NVMe? Let's do NVMe. So that's how we started doing the NVMe. And basically that took us best part of a year to fully develop the technology. And while we were developing it, he says to me, well, look, if I'm developing NVMe, why don't we do why don't we look at storage as a whole? Because the RISC OS storage system is somewhat antiquated in the sense that Acorn designed it many, many years ago, probably in the 1980s, around floppy disks at the time. And there's a lot of cruft is probably the best word I can use, relating to old disk technologies that are present in the way RISC OS does everything. And what we looked at was sort of, what do we want a modern storage system on RISC OS to look like? And so what we've developed, and it's not just an NVMe driver because, that's a bit passé. What we've developed is a whole platform, whole foundation, which we've open sourced, to deliver modern storage on RISC OS. And what we're doing is following a similar paradigm to the Linux and Unix world, where we have the concept of block devices. And software, etc., only needs to be aware of the fact that it's a block device system, rather than actually what hardware is present. So rather than software needing to be, if you look at something like John Albert's partition manager, he's had to write versions of that for practically every different RISC OS interface that's ever been created, be it SCSI modules from the A3000 era to IDE, multiple different IDE devices and all sorts. So basically, you have to reinvent the way RISC OS has worked historically. You have to reinvent the wheel every single time. With block devices, the idea is that essentially you just plug into block devices, you present yourself as another block device, and then all of the block device stuff will work with your new piece of hardware or filing system. So the amount of work for an individual programmer to do is quite minimal to go beyond this. So if you want partitioning, and you write a new block device driver, you'll get partitioning because it's already been done for the NVMe. If you want RAID, well, as long as the RAID bit exists, you've just got RAID. And maybe you want to mix an NVMe drive and something else. Well, it doesn't matter because they're all block devices. And so technologies like partitioning, RAID, SCSI, etc., all block-based concepts. Even things like CDs, the way it's done in the rest of the world is block-based. Just slots into the block device driving system, and you've got a much more coherent storage thing. If you want new file formats, new disk formats, etc., plug them in, everything benefits. So it's a much more joined-up solution to storage. Of course, it does all of the old stuff too because it's RISC OS. So your user experience is just the same as it always would be, but what you've got is a system designed to be expandable. And what started out like with just an NVMe driver, we've now got the ability to do multiple, you can have multiple file code partitions, for example, so you can take a big disk and split it up into smaller portions, or you can share the disk between sort of a FAT32 and a file core, etc. And we have that available to all the block device system. 4KN disk support, bolts in, everything works. So, when developing the NVMe driver, the programmer actually wrote a sort of RAM disk plugin for the system that allowed him to sort of simulate a RAM disk that was actually very similar to an NVMe device. It made it easier to debug, where you just keep debugging a chunk of memory rather than debugging an actual physical piece of hardware. But he just created that in a matter of just a couple of days, just bolted it in, and it suddenly got all the same functionality that the NVMe system had, because block devices. So we've created this architecture, and that's what's powering, when we talk about Project Next, that's what we're talking about, NVMe Extreme Technology. And that's powering everything from Pinebooks to Hydra to MiniPi has PCI Express slot, and the next boxes, and we've got next boxes with CD drives. So if you want a machine with a sort of CD drive, an SD card reader, and all the goodies, you've got that on the stand too. So it takes you right from cheapest little machines, and we're selling these for $199 with the NVMe storage, up to complete systems with all the bells and whistles, or Hydra at $599 with multiple CPUs and operating systems and all sorts. So essentially, it's one project that supports a range of different machines, delivering state-of-the-art technology to all of them. Yes, I'm told by Chris Hall, who's done some benchmarking of these things, that the NVMe technology that we've developed, the drivers, are delivering basically the fastest performance available for RISC OS. So it's paying out in spades that all of these machines benefit from that. Of course, it's not just about speed, but if you're buying a machine, you want it to be really good. But also, as well as speed, you want compatibility, and that's so you've got the compatibility with different machines. You also want compatibility with hardware. So, because I run out of solid-state, run out of NVMe drives earlier in the week, I sort of did the ones I had been using. Basically had gone out of stock with the suppliers, so I ended up having to do a sort of scatter file. I'll have one of those, and see how they all performed. And as some of you may be aware, there is another NVMe driver out there that exists. It was created after we'd announced that we were doing ours, so, and I don't think the source code to it has been. They said it was going to be open source, but it has been fully open sourced yet. So we've had to continue developing ours. But when I tested those drives, these were just cheap NVMe drives from Amazon. So we just selected some of the cheap, not the Chinese garbage, if you don't mind saying, but just cheap, affordable NVMe's that you might pick up off the shelf at Amazon. I bought 4 of them, different makes and models. All 4 of them work with our driver. No changes required, no modifications. None of them worked on the competing NVMe driver. So that's when I say compatibility, speed, device compatibility. We needed support for the Pinebook. So to those who said, well, why have Arcom developed an NVMe driver when there's another one in existence? Well, we started first. We built it on an open source platform. We support multiple different pieces of hardware. We support a much wider range of drives and devices, and we built a whole ecosystem to make RISC OS storage better as a whole. And hopefully that justifies the development of the existence of 2 products. I think we've tried to build something that is more than the sum of the parts, and deliver something that's really, really good. And obviously then this technology then powers all of the machines that I've talked about. And if you'd like to, you've got the next box available in different, the silver version, the black version, and what have you. So you can come and see that. And then there are sales full-sized versions, and what have you. I'll come back to Hydra in a minute, but because time is always limited, I'll talk briefly about monitors, because the screen that you connect your computer to is probably the most important part of it, really. Is how you see the computer, it's how you see what you're doing on the computer. And we often find people running sort of quite old screens, maybe 10 years old, that they bought for an old machine, and it's good enough. But the problem is that the screens get dimmer with age, and what was once a really good screen is a bit passé these days. And modern monitors, RISC OS traditionally has been limited to just 60 frames a second. But if you buy a modern monitor, you could have done it again.
Hold it down with a red light.
Okay. Modern monitors are often capable of so much more. So you'll see on the stand we have OLED monitors and modern IPS screens at different price points. But it's quite normal for a monitor these days to be able to be not just 60 frames a second, but 175 frames a second, 240 frames a second. Huge numbers. And that gives a smoother, faster experience when using your desktop. Things are clearer, the sort of blur that you get with motion on all LCD monitors is largely removed by having the faster refresh rates. Now, RISC OS traditionally hasn't done this, and what we found was that if you try auto-monitor problems, people say, oh, just use the EDID, the automatic monitor recognition, and that will solve the problem. But it doesn't, because when you use faster refresh rate monitors, you discover that either, I don't know whether it's RISC OS or whether it's the Pi hardware or what have you, but they don't get on when you just use the EDID. So, for example, monitors that I'm showing on the stand, one of them using EDID could only do 30 frames a second. The other one couldn't do anything and ended up reverting to 644/80. And if you try to set it to its native 25, 60, 40, 40, it stiffs the machine and the computer doesn't work at all. So EDID is not the answer to this. And this is not just like selected monitors. These are just sort of two monitors that I bought because they were good monitors that I saw. I just bought them, and neither of them have performed anything like what they should do via EDID. So what we're seeing is essentially that the hardware that RISC OS runs is not comfy with what the monitors are saying that they need for high refresh rates. So what we've done is to develop high refresh rate drivers which will allow you to unlock much higher frequencies on these monitors. So if you've got a 1080p screen, we can do that at 175 frames a second instead of 60 frames a second. So that's a huge, more than doubling nearly tripling the smoothness of the display. The 3440 1440 super wide that we've got on the stand, the OLED. On an ARM X6 that's doing about 30 frames a second, but on a Project Next machine we can do 96 frames a second. There's nearly 100 frames a second, and more than 3 times the smoothness that we could do on the older computers. So we've developed these drivers, and we've also developed lots of other screen modes. So even if you aren't using a high refresh rate monitor, you're shooting a 60 Hz monitor, we've got lots of in-between modes that are not exposed by EDID. So EDID only basically tends to show you a handful of modes that the monitor will do. If you're looking at sort of widescreen monitors like 1080p, you'll often find they give you 1080p or they give you 720p and no other widescreen modes in between. Well, what if your eyesight's not 20/20 and you just like a little bit of magnification? Well, with EDID you're basically stuck on RISC OS because we don't have a lot of scaling built into the operating system. So with our drivers you could have 1600 by 900, or you could have, I don't know what the actual mathematical numbers are, but the sort of 17 something by 1000, or resolutions in between. If you've got a 4K screen, most of the 4K screens tend to look really, really tiny. The icon box is a tiny strip if you want it actually at 4K. But with the with the drivers that we've got, you could run it just a little bit down, but get a nice comfortably sized icon bar, comfortably sized text. Maybe you're running it at instead of 3840, maybe you're running it at 3200 or 3600, just a bit down, but it gives you a much more easily readable picture and much more comfortable to use these kind of screens with RISC OS. We've also included in that software a whole load of our tools for sort of like recovering from bad screen modes, the USB video driver that we developed with Pinebook, titanium multi-monitor drivers, all sorts of things, and drivers for a range of different machines. And we're selling that at the show for £14.99. So if you've got an existing screen, you'd like to get the most out of it, £14.99. Or if you buy a monitor from us, maybe you want to have a nice new high-resolution screen, then the drivers are free of charge with any monitor that you buy from us. So come and check it out. The OLED in particular is well worth checking out. I mean, in the industry there is a term called delta E, which is how you measure colour accuracy, and they say anything around sort of say 3 or lower is pretty decent, good enough for sort of print work. A well-calibrated screen might get sort of maybe a delta E of 1.5, and truly professional screens would advertise themselves at maybe a delta E of 1. Out of the box, the OLED monitor that we have there, which was not super expensive, I mean it is expensive, we're selling them for I believe about £700, but you can spend £1,200, £1,300, £1,400 on similar products. So this was, for what it is, it's a relatively affordable one. Came with a delta E of just 0.38. So that's near as damn it perfect calibration. I mean 0 is considered perfect, but you would never see a 0 delta E in practice. But out of the box, no calibration required. Delta E 0.38 in a consumer grade product is just unheard of. But that means that in practice the RISC OS user can run programs like Photodesk or Publisher, Ovation Pro, etc. with complete colour accuracy, near enough, for you can have you can have that OLED monitor plus the next and still pay less than an Ionics cost you when you bought your Ionics, and that's pretty amazing. It's sort of that level of accuracy, that level of quality is available. It's not cheap, but it's not, and that's without taking inflation into account. I mean, if we took inflation into account, you'd probably buy 2 of them for what you pay for an Ionics, let alone a RISC PC. But it shows you what is available in the consumer space now to really get something quite special. But even if you don't want to spend that kind of money, the high refresh rate IPS provides very good picture quality. Certainly, down in somewhere in the 1 to 2 range of the delta E, I would have thought. I haven't actually measured it, but it's a very, very good picture, and that we're selling for just $299. So it's not, and that's for a 31-inch display. If you go down to 27-inch, then you can knock another sort of 60-70 quid off that price. So really good quality picture is not out of the realms of what people can do on their computers these days. And modern monitors also have features like some of them will do KVM functionality built into the monitor, so you can connect multiple computers and USB connections to the monitor, and then when you switch inputs, the USB switches at the same time. So if you've got a keyboard and mouse connected to the monitor, and you've got like a laptop connected to the screen, and your RISC OS machine connected to the screen, when you switch between them, then the keyboard and mouse will switch to the laptop and to the RISC OS machine at the same time. You'll often have speakers built into the monitor. I always try and put speakers in the monitor that we sell because it's just convenient to have it. Often, most of them are height adjustable. Some of them can be rotated, although RISC OS doesn't really do rotation. But there's a lot of flexibility in modern screens, and people don't necessarily have this on the current things. And it's sort of worth being aware of what is available in the technology. I'm sure there's more that I'm supposed to be talking about. Hydra, and then I'll do games quickly. Over the summer, earlier in the year, we launched an updated port of Hexen. If you're interested, come and see it on the stand. It's a lot of fun. And we also launched Heretic over the summer as well, modernising these games to support widescreen resolutions, 24-bit colour at high resolutions, revamped music, so you've got the old music used MIDI equipment, and basically all the video has been recorded now as digital audio, so the game will automatically use that digital audio recordings on computers to give you essentially a really good soundtrack, where previously MIDI RISC didn't really have fantastic sounding MIDI synthesis on it, so the digital soundtrack sounds really, really good, allowing it makes the game sound, look and sound really, really good. So strongly, if you've got any interest in games, check out Heretic and Hexen. And finally, we'll just talk about the Hydra, because that's sort of the ultimate of the sort of next technology. So you've got your high-speed NVMe drive. All of our machines, by the way, I always insist that we have 2 drives in the system so that you've got automated backup and recovery with our special recovery system. So basically, your machines can be, if you ever had a problem with a hardware failure, by having 2 drives, you can always recover from one or other if you ever have a problem. So we always make sure that any machine that we sell is capable of doing this, because I always think it's really important that you protect your data with your computers. So that all of our machines come with Safe Store, for example, so that they can be so you can back up your data automatically. But Hydra takes things to a new level by allowing you to have up to 6 processors in the computer, and each one is accessible through RISC OS. And so, for example, in this one here, I've got 2 processors. Each one is a quad-core compute module. So you've basically got 8 processor cores in here. And each one's got 4 gig of RAM, although you could have 8 gig on a Linux one. And basically, that means that we can run RISC OS and Linux at the same time. So if I open a window on this, I think possibly because I'm running at a low resolution on the screen, it's something slightly wonky has gone on there. Because it's set to do a 1080p display, and we're at 720p on this monitor, so it's probably not the best example. But we can run programs like Chromium for web browsing. If we go to Office, we run LibreOffice. We can have these programs running directly in a window on the RISC OS desktop. We can use these programs, despite them being used for other operating systems. So basically, that's LibreOffice running in a window on your RISC OS desktop, and we can share files backwards and forwards. So you'll see that we've got a shared drive. It's a cluster fuss designed specifically for the Hydra project, and that's got a RISC OS user guide in there. If we although it's hard to read, we've got I can't do this standing up down to it, it's quite awkward. But basically that there is, we've got the user guide on RISC OS, we've got the user guide on RISC OS and Linux, and basically what I'm showing is that they can both see the same files, share files between them, and so you can put documents onto the Linux head, as we call it. You can take documents off the Linux head, so So if you're browsing with Chrome, for example, you can then download things and then just transfer them to and fro. If you're doing your email on RISC OS and you get a document that you can only open in Microsoft products, you can dump it straight onto the shared drive and then open it in LibreOffice on the Linux head, and you can access that in real time in a window on your desktop at the same time. So essentially, it's the kind of technology that you had with like a PC card or something like that back in the RISC PC era, but brought up to date with modern technology. So you've got essentially a state-of-the-art Next system coupled with state-of-the-art NVMe powered Linux Pi system, all in one box, running at the same time, giving you the benefits of both operating systems, software compatibility, of two operating systems at the same time without having to say, oh, I want to reboot it to Linux, switch it to Linux, copy the files, oh, I forgot to transfer that file, go back to RISC OS, switch back to RISC OS, copy the file, back to Linux. You can just drag and drop them between the two language systems on the fly in real time, and just use them as you go. And then they can share resources, you can print the same printers and all this kind of thing. We even had Uniprint set up, doing all of Uniprint stuff between the two heads. So, so I could set up a printer on Linux and print directly to it from the RISC OS app, or I could cut and paste and launch URLs into Chrome on the Linux head. It's amazing what kind of stuff we could do with it. But basically, each Hydra, I spent about 3 days building each Hydra, and we actually tailor the Hydras specifically to the customers that are receiving them. So we set them up for your network. I'll ask you what you'd like to have each machine called, what IP addresses you'd like it to be using, and we'll plug it right in for you so that basically you get your computer, you turn it on, and all of this functionality just works out of the box, no setup required, for your setup and what have you. So the Hydras are, if you like, our most deluxe system, our most bespoke system, and basically we build each one to order with your choice of processors, how many processors, what level of file sharing you want between the different processors, how big drives you want on each head. You could have we did one with 2 terabytes Linux store for bulk file storage. We build them specifically to your requirements and get them, just so for your system. And then when you deliver them, fingers crossed, you just plug them in and go with the best possible system we can do. So I'll stop there because I've probably bored you all to death. I feel like I've been talking for a while, but basically, we've done lots of upgrades. We've done lots of things with NVMe, which is basically the fastest and best things you can do on RISC OS. And because of the whole 32-bit, 64-bit thing, these are probably the best computers for 32-bit RISC OS that there will ever be. So if you're sort of thinking, oh, I could get by with my old Pi 3 or IMX6, these are the best machines that you are likely to ever see for 32-bit RISC OS, because anything coming, Pi 5 is 64-bit, replacements for the Pinebook 64-bit. Some of them have 32-bit modes on them, but the problem is the 32-bit modes tend to run really slowly. They'll have like fast cores and slow cores, and you might get 32-bit on the slow cores, but then you'd actually be getting a slower computer than what you're getting now with the current generation. So that kind of defeats the point if the new product ends up being slower than the old product. So bottom line is, if you are interested in having a really good RISC OS computer, I would strongly suggest that now is the time to buy it. And you've seen with the Pinebook that it's sort of last orders before they move on to 64-bit. Pi compute modules are supposed to be around for a few more years, but sorry, brain's crashed. But once it's gone, it's gone. So I would just strongly urge you to please come and talk to me, check it out, see what looks good to you, try it out, find out all the bugs, and enjoy RISC OSing into the future.
shown us these beautiful photorealistic OLEDs.
Yep.
Do we have in RISC OS software like Adobe Photoshop?
Well, we have Photodesk, and obviously we brought Photodesk back in the last couple of years, so anybody can upgrade to the latest Photodesk, and that can do some pretty impressive things. But it's not Photoshop, what it is. But you know, if you haven't got the latest Photodesk, then I would strongly recommend checking it out and upgrading to the latest Photodesk. And using that alongside programs like Ovation Pro and what have you, you can produce some amazing stuff.
Are you going to do any work on Wi-Fi for the original one?
Possibly, but it is a completely different chip, so it's basically doing a complete driver from scratch, which is not a small. Over the summer, one of my colleagues has been doing a USB-based driver for Wi-Fi, and that's taken him about 4 months to do. Now, he does say that having done the work, it will be faster next time, but it's not a small job to do that. And to be honest with you, we may well just say, look, the USB driver, if you plug in a USB Wi-Fi to it, will give you Wi-Fi on the original Pinebook, and it may be a more cost-effective solution just to do that than us charge you 50, 60 quid for a driver that takes 4 months to develop. And you know, if you can just plug in a USB one for 20 quid, then it's a bit daft for us to charge you for all this development. You know, it may be just as simple as to go with that route as being a way of doing Wi-Fi on the older Pinebooks. Never say never, but I just don't want to make you a promise and not be able to keep a promise, you know. I mean, certainly on a spiritual level, I would like it to be so, but I'm also aware that there's so much programming to do for RISC OS, and there's only literally a handful of people who can do it. It's hard. Quite difficult to justify spending 4 months programming time on a machine that is now, by its purposes, obsolete, unfortunately. It's still a good machine, don't get me wrong, but those haven't been made in a very long time. Since before COVID, it stopped production in COVID.
Do you support any USB plug-in DVD drives on your machine?
Yes,
you do.
You do, yeah.
Okay. I don't want a DVD in the machine, but I'd just like to plug.
Yeah, I mean, the only thing I would always say with DVD drives, USB DVD drives, the main problem that you have with them is power.
Right.
Because a normal USB 2 port can only deliver half an amp of power, and most DVD drives need a bit more than that to spin the disc. They'll start spinning, but when it's spinning at high speed, it needs more power. So we tend to recommend using USB 3 ports, maybe a powered USB hub, USB 3 hub, to make sure they have enough. Because often they just use a single cable and they expect to be able to pull all of the juice from a single cable. Sometimes you get 2 cables and that's fine, because they can pull half an amp from each.
Work in any kind of current RISC OS machines.
That's probably down to the drive then rather than anything else. But but in principle,
It's okay, fine.
Yeah.
So,
the other thing is if you own something like an ARMX6, I mean, this is what I said to somebody else recently. They said, oh, well, what will I do with my ARMX6? Well, you put it under the desk, access it remotely using the VNC or what have you.
Yeah.
And if you type share CDFS0, you can literally share the CD drive over the network and plug your CDs into that and just click on the icon on a modern machine. So.
it's not one of our the children play under my desk.
Right, well, okay.
I have my ARMX6 networked to my Onyx and my 42. They're all networked.
No, exactly. So basically, I tend to think that it's a good use for some of the older machines just to read those CDs off. And to be honest, since a lot of CDs are decaying, that's another side point. CDs suffer bit rot. So if you do have old CDs, it's worth just copying all of them off into a USB stick, put them on a USB stick, folder on a USB stick, or put them onto your network and attach storage or something like that, because certainly the burned discs that are quite common in the RISC OS world, sort of 10 years, chances are they're going to be dying. Well, yeah. So yeah, get your data off the CDs is generally a good plan, and onto something. Anyway, oh. Final one. Final one.
Sorry.
Yeah.
Your smart devices,
Yes.
what file systems do you have?
At the moment, it's file core and file propositions. I believe that there's sort of also well, there's more coming essentially, but because it's open source and extendable, we'd like to start introducing support for better filing systems that allow us to go beyond the usual RISC OS limits. So I mean, the obvious thing we could do sort of unlock some form of I'm blue skying here, so don't quote me on this, but to do something like a Linux filing system, Linux-based filing system, open source filing system on there to allow more capacity. But don't quote me on that because that's quite a lot of work. But that's the kind of thing that block devices is designed to facilitate, because that's the sort of same architecture that those filing systems come from in the rest of the world. So at the moment, file core, yes, with 512 and 4K sectors. With one or more file competitions, but hopefully we will be able to unlock more in future to develop on from there.
I don't have a question, just to say to everyone, it's lunchtime, the bar is now open. So,